I'm not feeling too good. Maybe I should go to the doctor.
Hello, CSL. How are you doing? You look a bit under the weather.
I feel a bit sick. I wanted to come in to make sure my protein synthesis is still on track.
Okay, let's give you a checkup.
Okay. Hey, doctor, what is the point of protein synthesis anyway?
Protein synthesis is a natural process that your body undergoes to create proteins. Proteins help your body perform daily functions, create enzymes, and provide structural support. There are 2 steps to protein synthesis: transcription and translation.
Right.
It starts with transcription.
Transcription is the process by which a cell makes an RNA copy of a piece of DNA. This RNA copy, called messenger RNA or mRNA, carries the genetic information needed to make proteins in a cell. Transcription occurs in the nucleus of the cell. In order to make mRNA, RNA polymerase binds to the DNA strand. RNA polymerase is the main enzyme involved in transcription. Once the RNA polymerase is bound, the RNA recognizes the start of the gene and starts to unwind this portion of the DNA. Next, the polymerase builds the RNA strand out of complementary, free-floating nucleotides. The RNA transcript has the same complementary coding as DNA, but it contains uracil instead of thymine. Finally, once the RNA strand is complete, it separates from the DNA template and is now transcribed.
Your ability to transcript seems to be fine. Maybe the problem is in your process of translation.
What's translation?
Translation is the second step in protein synthesis. Translation takes place in the cell's ribosomes, located in the cytoplasm.
After transcription, mRNA travels to the ribosome in the cell's cytoplasm to undergo translation. First, tRNA, transfer RNA, carrying methionine, the start codon, binds to the large subunit of the ribosome. Meanwhile, the small subunit of the ribosome starts to read the mRNA. The mRNA arrives in the P site of the ribosome. The A site will be the arrival site for the next tRNA, which will have an anticodon that's a complementary match for the exposed codon. Secondly, once the matching tRNA has landed in the A site, the ribosome forms a peptide bond between the amino acids of the 2 tRNA. Finally, once the peptide bond is formed, the mRNA is pulled through the ribosome by the length of 1 codon. This shift allows the first empty tRNA to leave through the E site. This also exposes a new codon in the A site, so the whole process can repeat. Eventually, the stop codon in the mRNA will enter site A and the process stops.
There don't seem to be any problems with your protein synthesis. But I did run another test, and unfortunately, you have the flu.
Okay.